Hello everyone, I am Salman Patan from Study with Salman. So today we are going to see a problem based on step bar. The question is that a step bar made up of steel with modulus of elasticity 200 gigapascal and it is subjected to a force of 5000 Newton, and we need to find nodal displacement, element stresses and support reaction. This is the given problem statement figure. Here you can see that all the dimensions related to area and length are given in mm and force is given in kilonewton. So in given data, first of all we will write the given dimensions or the given data. Okay, so the given data is area is a1 is equals to 50 mm square, a2 is equals to 40 mm square, a3 is equals to 30 mm square. Then L1 is equals to 25 mm, L2 is equals to 40 mm and L3 is equals to 50 mm. Then after that the modulus of elasticity is given in gigapascal, so we need to convert it into megapascal. So we know that 1 gigapascal is equals to 10 to 3 megapascal. So after converting gigapascal to megapascal, we will get 2 into 10 to 5 megapascal. Okay, now moving towards the solution. So first step is preprocessor. In preprocessor, first of all we need to discretize the given problem. So the given problem will be replaced by nodes and elements. So this will be replaced by node 1, this will be replaced by node 2. Similarly, this is node 1, this is node 2, this is node 3 and this will be node 4. Similarly, we know that by joining two nodes we get one element. So this will be element number 1, this will be element number 2, this will be element number 3. So here in this discretized diagram you can see that we have discretized the given problem, and as in given problem we need to find nodal displacement. So we have taken the nodal displacement as well as the force of each node. So for node number 1 the nodal displacement is u1 and force is f1. Similarly for second node, node number 3 and node number 4, as in problem it is given node number 4 with force of 5000 Newton. So in discretized diagram you can write that f4 is nothing but the value of f, which is nothing but 5000 Newton. Okay, now moving towards next step. The next step is element stiffness matrix. So first of all we need to decide the size of element stiffness matrix. So for that there is formula. Size of K matrix is given by size of K matrix is equals to nodes in element into degree of freedom per node. So here by joining two nodes we get one element. So nodes in element, so for single element there is two nodes. Okay, into degree of freedom per node. So degree of freedom of single node is nothing but 1, so the size will be 2 by 2. Okay, and the number of element stiffness matrix depends on the number of elements present in the given problem. So in present problem there are total 3 number of elements, so there will be total 3 element stiffness matrices. Okay, similarly we need to find the element stresses. So there are 3 elements in given problem, so element stresses will be 3. Okay, sigma 1, sigma 2 and sigma 3. We will see in next steps how to find out that stresses. Okay, so coming towards the current finding out the element stiffness matrix. Okay, so the formula for finding out the element stiffness matrix is Ke is equals to Ae into capital E E by Le in matrix form 1 minus 1 minus 1 1. Okay, so in given problem the values of A1 then capital E1 then divided by L1 are given. So we just need to put the values of AE and L, and after that you will get 400 into 10 to 3 as the answer. And after putting that answer in next step we need to put that in element stiffness matrix. Okay, so here we can multiply this 400 in with the matrix. So after multiplying that you will get 10 is to 3 out of the matrix, and inside the matrix 400 minus 400 in second row minus 400 and 400. This is nothing but the positions of the nodes, so we can denote as 1 2 1 2. Okay, similarly for uh, second and third. Okay, so this is second element stiffness matrix and this is third element stiffness matrix. For solving this you just need to do a simple calculation. Okay, then in next step this is nothing but the position of second node, then this is third, second, third, then respectively third, fourth, third and fourth. In next step we need to form a global stiffness matrix. So before forming the global stiffness matrix, we need to decide the size of global stiffness matrix. So the formula to decide the size of global stiffness matrix is given by total nodes in body into degree of freedom per node. So in given discretized diagram, you can see that there are total four number of nodes. Okay, this is 1, 2, 3 and 4. Okay, so here will be 4 into degree of freedom per node will be 1, because one node has 1 degree of freedom. It is one element and the size will be 4 by 4. So now how to form this global stiffness matrix? So for formation, you just need to put this position like this is nothing but the position 1 1, this is position 2 1, this is 1 2 and this is 2 2 in the global stiffness matrix. So here on the top we will write 1 2 3 4 1 2 3 4. Okay, and we will take the elements from this element stiffness matrices. Okay, so this will be placed on that position. Then after that, this second and third second and third will be placed inside this global stiffness matrix, and the order will be 0 because the values of other positions are not mentioned. Okay, so that will be taken as 0. And after that, uh, we need to find the deflection. So for that, there is a relation between force, stiffness and deflection, which is given by F is equals to kg into u. Okay, this F is nothing but global force vector, this kg is global stiffness matrix and u is global nodal displacement. So in given problem, there are 4 nodes, so that will be subjected to total 4 number of forces, and they will have total 4 displacements. Okay, so after that, in next step, we are going to apply the boundary and loading conditions. So as you you can see in the problem, the node number 1 is fixed one, so the degree of freedom of node number 1 will be 0. Okay, so u1 will be 0, and node number 4 is subjected to force of 5 kilonewton. So we are going to put the values of force as well as the displacement. So 5 kilonewton is nothing but 5 into 10 is to 3 newton. Okay, so we will take 10 is to 3 as common, and 10 is to 3 common from global stiffness matrix. Okay, then after that, as we know that u1 is fixed, so the value of u1 will be 0, and u2 u3 and u4 will be as it is. Then in next step, we are going to apply the elimination approach. So as we know that u1 is equals to 0, so by elimination approach, the first row will be entirely deleted. Okay, then first column of global stiffness matrix will be deleted, and 10 is to 3 10 is to 3 will be deleted because it is same on both sides. Then after that, this is the uh, simplified matrix. Okay, and after that, we just need to write this in the form of algebraic equations. So we have written this in form of algebraic equations, and with the help of calci, we have to solve these algebraic equations, and after solving, you will get values of u2 u3 and u4. Then after that, the next, we need to find elements stresses. So for finding element stresses, there is formula element stress is equals to E into B into Q. And after solving or simplifying this, you will get sigma 1 is equals to E1 by L1 in matrix form minus 1 1 U1 U2. Okay, so let us solve for stress number 1. Okay, so the given values of values are, the value of E1 is 2 into 10 to 5, the value of L1 is 25, the value of U1 is nothing but 0 because it is fixed one, the value of U2 is 0.0125. Then in next step, we know that 2 into 10 to 5 divided by 25 is equals to 8 into 10 to 3. Then in next step, we will multiply this 8 into 10 to 3 inside the matrix, and after that, you will get minus 8 into 10 to 3 as first column first row element. Okay, and second will be second column and first row element as 8 into 10 to 3. And in next step, we just need to multiply this matrix with this vertical matrix. Okay, that is column matrix, and after simplifying, you will get sigma 1, that is stress 1 is equals to 100 megapascal. Similarly, you can find sigma 2 sigma 3. You just need to change the nodal displacement matrix. Like for finding out sigma 1, you have to take u1 u2. For sigma 2, you need to take u2 u3. For sigma 3, you need to take u3 u4. and after that you will get the answers, respective answers. Okay, then the last is you need to find support reaction. So by using this equation, which is given in terms of force, we are going to write in terms of reaction. So here we are going to replace f1, f2, f3 and f4 by r1, r2, r3 and r4, and we will write this entire matrix as it is. Now in next step we are going to apply the boundary conditions. We know that the values of r2, r3, r4 are 0 because there is displacement at r2, r3 and r4, but at r1 there is no displacement because that node is fixed one. So you just need to remember that the point where the displacement is 0, then at that point there will be a reaction. Okay, and you just need to find the value of that reaction. So here there will be reaction r1. Then after that, in next step you just need to find the value of r1. So r1 is equals to 400 into 0 minus 400 into 0.0125 plus 0 into 0.0375 plus 0 into 0.079, and after simplifying this here into 10 is to 3. Okay, and after simplifying this you will get r1 is equals to minus 5 kilonewton as a final answer. Okay, thank you very much.